Hey everybody, this is KD0FNR. I'm trying to keep better notes on my radio ops, so that's why I'm just getting a few quick thoughts down this morning. I ran a straight key month K3Y/6 shift this morning from 4 until 8 local time. So in the graphs I'm going to show you, that's going to be between, we had 8 hours, so that's going to be between noon, yep, and 1600 UTC. So over that time, I woke up an hour late, so I didn't get started till 5. And I made 3 QSOs. The first one was out to N7DR here in Colorado. The second one made it all the way out to Maryland about an hour later, and that was H6AX. And then the final one right at 8 o'clock was over here to Indiana, and that was November Juliet 0 Utah. And the things that I find that are a couple of things that are interesting. First, all 3, you can see I'm getting spotted other places, but all 3 QSOs are right along the same geodesic between San Francisco going out to Maryland. So that's kind of cool, I think. And then when I went to look at what propagation looked like, this is a propagation out to Maryland. And so if we go, that's HMF2. I'm just resetting the data a little bit. And here is FOF2, so let's reset that a little bit. And so what you can see is that I made my QSO out to Maryland at 1407. And so this is UTC. This is 1145 UTC. And so if we look at FOF2, I am in no way, shape, or form where I normally am as far as critical frequency anywhere. In San Francisco, critical frequency is at 3 megahertz. Halfway out to Maryland, critical frequency is at about 4 megahertz. Maryland is not even there. Okay, and so we move ahead. And then we go to 1215, and what we're wanting to see is 1415, and so we're getting out there. And when we hit 1415, that's when I made the QSO at 1407. Still not critical frequency here in San Francisco, but that doesn't matter as much. What matters is, are we there halfway out to Maryland, which looks like it's about 33 degrees of arc along the surface of the Earth. And so we're going to come back to about 17.5, and you can see that we're at 6 megahertz. And I don't know if the angles will work out, but there's something called the secant law. And that says that you take the critical frequency, multiply it times the secant of the angle from San Francisco up to the F2 layer. And then that gives you the maximum usable frequency. So I'm going to try and play with that calculation later. But let's talk about the height of the F2 layer. So here's the F2 layer about the same time. And this is, again, looking all the way out to Maryland. So we're starting in San Francisco, going out to Maryland. And so, again, it started at about 11:15. We're gonna go up to 14:15. To see where we are at that point. And you can see it was pretty high to begin with. We get out to 1415 though. There we go. It's actually kind of normalish to low. And so you can see that it's at about halfway through. Yeah. So it's at about 275 or so, 275 kilometers up. So yeah, we started out with a really high F2 layer. By the time I made the QSO, went back to low. I don't have numbers for N7DR yet. When I do, I'll get those posted. But anyway, just wanted to capture a few notes. This QSO out to Maryland is really interesting to me because it doesn't, I guess by the time the QSO happened, FOF2 was getting to be high enough that we could pull it off. But again, a kind of common thing I've seen in these, The height of the F2 layer doesn't seem to make as much difference. Anyway, this is a KD0FNR. I've got Radio Dog Cooper back there. I am going to go take that puppy for a walk and get started on my day. 72s, everybody.
Dun, 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 toucan radio.